Okay, thanks. I hope you see the presentation mode now. Okay, cool. Yeah, thank you. Thank you for the opportunity to present this work here in the conference. This is joint work with, among others, Paula, but also Isabel Braunga, Hannah Powers, and Alexander Krum. And so we've looked from a perspective of how to possibly advance ambitious climate policy with an institution like the Coal Commission, or in Germany. So we have taken a detailed look at the Commission and tried to, from that detailed look, maybe gain some more insights on if this might be a tool also for other cases in the future. Of course, in Germany, we have many more transitions and transformations to come, and also, of course, other countries. So far, there's, as you all know, limited progress in reducing fossil fuels, and that's one thing is that it's just resistant by incumbent actors that are about to lose by a phase out of, for example, fossil fuels. But on the other hand, also scholars have so far put limited attention on how political processes could look like to advance socio-technical or sustainability transitions. Well, names differ a lot. On the other hand, we've seen in Germany, but also many other cases, that stakeholder commissions, roundtables, etc., have come together to find common compromises and common solutions among the broad variety of stakeholders, and to thereby advance those processes. And our goal now was to look from a more theoretical angle also at all this, and there's quite some literature on collaborative governance, which we think kind of represents this process of these commissions, etc. And the major thing here is that it's this these structures of different actors representing these stakeholders that come together and try to solve a situation that might otherwise not be solved, or no compromise be found. And that's kind of the situation we experience in Germany as well, with the coal phase out. And in the literature, you find, of course, many pros for such collaborative governance processes. One major thing, of course, is consensus-oriented decision for highly contested issues, where otherwise no compromise could be found. On the other hand, of course, these comes with weaknesses, such as the marginalization of weaker actors and radical opinions, and also some others. Nevertheless, we thought, well, this might be a good frame to assess the Coal Commission and look at the potential of such institutions to advance major political changes. So far, in the literature, there's not too much of literature on how actually the effects of such processes look like. There's one major meta-analysis by Jager et al., and they find some, or a general positive effect of participation, looking at different schemes of participation and collaborative governance on environmental standards of the governance output. However, of course, the question is that enough to also achieve such major transformations that are needed for achieving a pathway for 1.5 degrees? And yeah, energy transitions are generally very highly debated and contested issues. So our question here, we wanted to assess, can these contribute to achieving required system transformations? The Coal Commission in Germany, actually called Commission on Growth, Structural Change and Employment, was set up of 28 members with voting rights, additionally 3 members from parliament without voting rights, representing the major stakeholder groups, not representing, for example, Global South or Fridays for Future. Then wasn't that big of a deal yet, so also the younger generation was not explicitly represented. After about 7 months, they came up with recommendations in their final report for a phase out and structural change measures. However, of course, and you all know that, the phase out recommendations by the Coal Commissions are really in line with a 1.5 degree target, which was the Paris Agreement ratified also in Germany. So yeah. Well, that's the background. We have chosen a theoretical framework to assess all this. That's the Integrated Framework for Collaborative Governance by Emerson, Nabachi, and Karlo. And we've done about taken 18 interviews with members of the Commission and Commission's office, and used qualitative content analysis to assess all that content of the interviews. Briefly on, and just I'll more or less jump over that, but you kind of see that this framework consists of different layers, and most importantly, what is the collaborative process and collaboration dynamics. That's what we looked at, how this possibly from the different outgoing situation of very opposed interests, if that could enable somehow coming up with climate policy recommendations that are more ambitious than maybe just a weak compromise. And don't go through that, but the collaborative dynamics consist of different elements, and we looked at those. So coming to our results so far, we've observed in the Coal Commission definitely some collaborative dynamics, however, only to limited degrees in some ways. So, for example, all members were committed to this process and showed efforts to also come to final recommendations, even though during the work there was a lot of debates and issues, and members saying, well, if it continues that way, we drop out or something like that. But in the end, even though they were had so much of opposing opinions, etc., they still stuck together and came up with these final recommendations that were approved by 27 of the members, and only 1 member did not approve. It has to be said, though, that especially the environmental pro-environmental actors and members stated that they were agreeing to the final recommendations, but not with the proposed phase-out pathway. That was not a strong consensus in that way, but rather some form of compromise to now move on with the phase-out, but not the final and all good solution. And that was to some extent due to to some extent not optimal collaborative dynamics that included, for example, that just the level of trust wasn't very high. Many decisions and debates only took place in exclusive rounds. For example, well, there was the institution of Friends of Chair that only included a few members, and only members that were well connected and had the possibility to bring themselves into that and were also chosen to participate. Others that represented, for example, the local communities had a lot more difficulties to represent their interests in there. So overall, we saw an environment that advantaged well-connected and negotiation experienced members. And as you can imagine, that applies rather to, for example, trade unions, industry associations, etc., and not so much to local actors that for the first time act on such a in such a high level political institution. Of course, that was only one part. The other part was, of course, the mandate, the selection of members, etc., that set the scene for all this. And that is, however, a complicated process, because if you exclude, for example, industry associations, they are in the political economy of Germany, for example, so powerful that they probably could be able to block, even though if recommendations come out of such a commission, but industry associations are not part of it, they could block the implementation. So it's kind of this leveling out and balancing out the interests and participation, and that's also represented, for example, in the mandate, that if the mandate would have set more ambitious targets than were already stated in political plans, possibly some stakeholders would not have been willing to participate. And all this selection of the members and mandate was also debated among influential actors that were connected to the government in the first place. So that's not something that's set in stone, and the selection of members or mandate always looks the same. And of course, even though not officially part of it with members with a voting right, the federal government choosing all the setting, plus having their contacts into the commission, providing also the compensation payments, etc., and also the lender, the federal government ministers, etc., had a lot of power in that process. So, as I said before, the need to involve those veto players or potential veto players was one issue, of course, and which forced a compromise somewhere in the middle. On the other hand, of course, the environmental actors only had a limited weight in those discussions because they couldn't offer very much. I mean, they could offer that they would agree to it and not organize more protests, but they not like industry associations saying like, well, if you don't pay high enough compensation, well, we move out production to other countries or something. And of course, it's in this context, most issues are well known. So discovering some unknown win-win solution seems rather unlikely. Yeah, and in the end, it's the incumbent actors that had to agree to a phase out and to a change to the status quo. So coming to an end here, collaborative governance and an institution like such a stakeholder commission might create new opportunities. For example, in Germany, it started the phase-out process, coming from an if of a phase-out to a when. However, on the other hand, it also kind of favors the continuation of incumbent structures that have quite a significant say in such institutions. And well, what we conclude is that it might be a possibility to bring together stakeholders, but for radical change, which is kind of excluded from the beginning, this is not really an option. Of course, we only looked at a single case and a very context-specific case, but still, we think this is something that, yeah, highlights the general difficulties of such an institution. Thank you very much, and looking forward to any comments, questions. Thank you.
Thank you very much, Chris. And thanks also for sticking to the time. Are there any questions by people? Then they could just raise their hand with the reaction symbol, type into the chat, or just speak up also directly unless someone else is already talking. If there are no questions by anyone else, then I would drop a first question. So basically, you examined, of course, the case of the German Coal Commission, but at the same time, we know that in Czech Republic, we've seen another commission which also came to a conclusion. There's now the big discussion, what should happen in Poland in the future. So would you recommend policymakers in Poland also to form a commission? And even if you would say that, no, I wouldn't recommend them to form a commission, if they would still have to do it for certain political pressures, what do you think are the main aspects that you would like to tell them to make sure that the coal commission, the way that it would be structured in Poland, would basically come out with a, I would say, optimal findings in the end from your perspective?
Yeah, thanks. So I think the difficulty is that, of course, you need, first of all, political actors to be willing to advance such a topic. Otherwise, there's, I mean, of course, we've seen that, for example, in France, or also now in Germany and other countries, these climate forums and of public society or the civil society. However, if they are not backed with the political mandate to actually recommend something that the government is later willing to implement, yeah, it's difficult to say what's that worth. If, for example, Polish government is willing to do something and change something, I guess it's important to have somehow a leveled out participation of different stakeholders, and that's something that hasn't really taken place in the German case, kind of also level out the playing field for actors that are not backed up by a large, powerful organization, for example. Give them advice, resources, staff to also really participate, and not only formally participate, but substantially participate. I guess then it's the mandate for such a commission that sets the scene. And well, from the perspective of no climate policy or no phase out policy to something that might advance the topic, and it is a major step. So actually, I wouldn't say that, for example, in the German case, it wasn't worth anything, or only implemented the status, or well, not status quo, but a weak climate policy. we've also heard from interviewees that, well, no one knew what would have happened if the commission would have failed. This might have blocked also on the European level further advances on climate policies. So yeah, of course, it's something that can help to overcome this some call it herding stalemate situation, or this blocking of, but it depends of course on the willingness of political actors in the first place to also then implement recommendations. And in the Czech Republic, the commission was set up mostly of more industry stakeholders, etc. They came to a conclusion, but well, now it's not really accepted by a large part of society. So legitimacy for those recommendations is rather low. And so far, it's not clear if what will be implemented.
Just putting this into context for people that might not know, the Czech government, the Czech Coal Commission also recommended 2038, basically in line with the German Coal Commission a bit later, but the environmental act parties, so to speak, that were members of the commission didn't agree on that, but literally walked out. And the government is now thinking of implementing a coal phase out faster than what the commission has recommended, because they don't believe in that slow timetable, just as a context for others. Thank you very much. Time is a bit to do. So if people have other questions, they could also just use the chat function and write bilaterally to Chris. But otherwise, I would say we continue so that we are not delayed in the first session already. So I will basically hand over the floor to Karlo Hainsch, and Karlo will basically now talk about a bit more from a technical perspective. How do we transition Europe to 100% renewable energies? And therefore handing over to you, Karlo.
All right. Thank you very much. Can you see my slide? Can you hear me?
Yes, perfect.
Perfect. All right. Then, yeah, good morning, good day, everybody from my side. And thank you for the introduction, Poyu. And my talk today will be tackling how to get to 100% renewable energy systems in Europe and Germany. So if we want to phase out coal, nuclear, coal, gas and oil, something else has to come, and renewables should be the prime option, which I'm going to illustrate in this talk. Also, the work I'm going to present here is basically the accumulation of a couple of years of research, which were mainly accompanied by Konstantin Löffler, Thorsten Burand, Poyu Oy, Christian von Hirschhausen, but also many others, which didn't really fit on the slide here. Yeah, shout out to everyone there. So a little bit of an introduction. Over the last years, basically the discussion of 100% renewable energy scenarios and systems shifted generally from a question whether it is possible and feasible towards how is it possible and feasible, which is already an achievement. And even until 2019, which was the last time where I found a comprehensive review of 100% renewable energy systems, there were more than 200 academic peer-reviewed articles which examined that. And since then, this number definitely grew. So it's time for a new review, I guess. And since in recent years, both the EU and Germany pledged towards greenhouse gas neutrality by the midst of this century, which not necessarily is 100% renewable energies. But the question arises, how could we get there? How can we get there? And therefore, in this presentation, I will illustrate 3 different case studies, which we conducted over the last couple of years. 2 of them tackle the plain question of 100% renewable energy systems, either for Europe or for Germany. In the Europe case, we use 2 different energy system models, one of which I will go to illustrate very briefly in the next slide, the other one also from our department. And then the third one is kind of a different angle on the question. And it takes a look at the German energy system transformation, and more specifically conducts a sensitivity analysis of different drivers and tries to identify key challenges as well as drivers for this energy transformation. All right. Now, Global Energy System Model Genesis Mod is an energy system model which we developed here at the Technical University of Berlin. It is based on a different or on another energy system model, which is called osmosis. And the main feature generally is that it is open source. So if you want to use it, if you want to take a look at it, maybe without using it, you can find it on the link, which you can see here on the slide. And if you want more information, you can obviously also always contact me. But it is publicly available to the community, both code and data. Also, all of our publications are aimed to be, are aimed to be publicly available, just to emphasize the issue and the importance of open source and open data. It's a linear program. It optimizes the net present value of the future energy system of whatever region and temporal scope which is chosen. And the main idea is that all the different energy sectors are included at once. So we're talking about general power demand, but also industry demand, residential household demand, as well as the transportation. And strength of these models are that interactions and interdependencies between the different sectors are very easy or easier to identify. However, of course, this comes at the cost of temporal or spatial granularity and detail. So yeah, it's always important to keep in mind what the models can do and what they cannot do. And with that being said, I will go into the results of the case study. So prepare for a lot of colorful graphs. Starting here, we are at the case study for 100% renewable energies in Europe. On the top left, you can see the primary energy demand until 2050. First thing, starting in 2040, there are no fossil fuels anymore. So we have solar, wind, hydropower, and biomass, and everything else is phased out until then. That's basically one of the ideas of the case study, was to analyze how this until 2040 could look like. And a lot of the results will look the same or do look the same across the different case studies that we did. So I'm usually only going to show them once. And for primary energy demand, we can basically always see that the demand goes down, which usually comes down to the point that electrification in other sectors, which currently are mainly fossil dominated, usually show higher energy conversion efficiencies than combustion of fossil fuels, which is why the overall energy demand goes down. Now, this does not hold true for power generation, which we will see in 2 slides. On the right-hand side, we see how the configuration for the power sector looks across the different countries. On the left-hand side for 2020 and on the right-hand side for 2040. I hope you can see a little bit on this slide. But generally, apart from seeing that currently a lot of fossil dominated and in some cases nuclear dominated electricity systems are being replaced by wind and solar, we can also see a little bit differences in the configuration or the share between wind and solar across the different regions, which should come at no surprise. But also that specific countries, like in this case study, Turkey, which was also included, significantly increase their electricity production, which does not only come down to their own demand increasing, but also since Turkey, with a lot of area, also had a lot of potential for renewable energy, serves a little bit as a generation hub for a lot of Southeast Europe. So electricity is transferred from Turkey to some of these other countries. Now, the bottom graphs were then compiled by a second energy system model, which is called AnyMod, and show an example load curve for one specific week in January in 2040 on the left-hand side for France and on the right-hand side for Poland. And we can see that first it's January, so the solar peaks really aren't that significant. Of course, we can still see them, but the overall electricity system is dominated mainly by 3 things. The first one is wind on and onshore and offshore in the case of France and onshore in the case of Poland. Then this purple line here is import. So the possibility of importing electricity from other European neighbors, where we can see that especially Northern Europe with a lot of wind potentials serves as an exporter of electricity, while Central Europe usually imports more, which is the case for both countries, although in Poland more dominant. And we have flexibility options in the form of batteries, mainly in France, which shift some of the load from specific hours, especially in the afternoon, evening, here in this case, or in the day hours to the night hours. And in the case of Poland, there is even hydrogen gas turbines, which basically burn hydrogen, which was earlier generated through renewable energies, because there's only renewable energies, but which serves as another mean of flexibility. Talking about these flexibilities, here we can see for 2030 and 2040 on the top left side, what the capacities for different non-intermittent capacities are, also still for the European case study. And apart from this very high graph here for the lithium-ion batteries, which have to be taken a little bit with caution because the modeling approach could lead to an overestimation of this number, we see that basically most of these intermittent technologies and capacities are there to facilitate the intermittent ones, which, for example, here we see that electrolysis and methanation are being constructed, which basically serve as sort of an energy storage, apart from the traditional energy store or electricity storages, which you can see here on the left-hand side. On the bottom left, we can see how the demand profile in 2040 for Germany looks like. Now we're talking about electricity. The black line is the reference line of the 2015 load. And in 2015, most of the electricity demand comes from, we call it here conventional electricity demand, which is basically everything you can imagine today which consumes electricity, which is mainly appliances, lighting, and then there's a little bit of electricity and some of the other sectors. This conventional electricity demand goes down by quite an amount until 2040 due to efficiency gains. However, all the other electrification in the different sectors, mainly in the industry sector, then here the darker blue one is mobility, and everything on top of that is residential heating. These lead to an overall increase in the electricity demand, and not only lead to a shift or like a variability of electricity demand between different hours of the day, which we can already observe today, but also to a more pronounced difference in electricity demand between different seasons, which raises a need which currently isn't as pronounced to sort of manage to get electricity to these months from October to March, whether it's through production there or some sort of storage. But yeah, so this is something we could observe there. And now jumping to the power or to 100% renewable in Germany, which is a different study which is built on work from 2019. This is now the electricity production. So compared to the picture of the overall energy demand in 2000 or for Europe, which was decreasing, we see that electricity demand is increasing, which is again supported by this picture on the slide before. Right, and in 2040, again, there is no fossil fuels anymore. There is limited degree of nuclear and coal in natural gas and coal in 2030 and 2035. But starting 2040, there is no fossil fuels left anymore. Also interesting is that basically until 2030, the overall electricity production didn't increase or doesn't increase that much and really starts ramping up afterwards. However, the shift here increases. So just because the overall electricity demand doesn't increase that much, doesn't mean that basically nothing has to happen until then, which is very much illustrated in the share of renewable energy compared to the one of fossil fuels in the earlier periods. As for capacities, so this is basically the picture behind the picture from the slide before. We can see that even though in 2040 there was no fossil fuel generation left, there are still capacities existing, right? So these capacities are still basically within their lifetime, and some of them even in 2045 and 2050. And this illustrates that even in 2040 here, we have capacities existing which are not being used, later periods as well, which raises the point that, well, we don't have to build realistically any new fossil capacities if these already exist. Now, of course, this only holds true at the level of aggregation, which we could use in our analysis. But these are significant capacities. If we take these together, we're probably talking about 35 to 40 gigawatt, which in this moment here are stranded or not being required anymore. And as for the last case study I want to highlight, which already also builds on a paper published in 2019, we tackle a little bit the question of uncertainty. So whenever energy system modelers make model runs or conduct analysis, there's a lot of input assumptions which have to go in there. And a lot of them, or basically all of them, regard the future, and therefore, well, we don't know how they're going to look like. We can get an estimate, but realistically, we don't know. There's different ways of including uncertainty into models. There's a way of including uncertainty directly into the model, but there's also the way, or a softer way of uncertainty analysis, which is sensitivity data or analysis. And sensitivity analysis generally describes a process where one specific parameter is changed and the result or the effect on the results is being analyzed. And this is one of these graphs as a result. I'm going to guide you through this a little bit. First, we had a base case. So the base case, this research started a little bit more than a year ago, included the political targets which were set by the German government until then, and the emission reduction in this base case reached 88.49% in 2050. This is the one reason why we're not talking about 100% renewable energies here. The second reason is that if we were already be talking about 100% renewable energy, the effects of the sensitivity analysis would be more limited because one side would already be kept. So this here gives us a little bit more insights on what the effects of different input parameter changes look like. The resulting scenarios, they land in the range of either 2 degrees Celsius global climate increase, or below 2 degrees, a couple of them even above 2 degrees. Now we did a lot of different sensitivities, a couple of them, or then, yeah, a selection of them you can find here. The base case is the one here in the middle, the brown grayish line. We took a look at grid expansion, so higher possibility and lower costs of grid expansion, more renewable potentials, so using more efficiently the available land or increasing this land mass, changing cost and efficiency parameter of breakthrough technologies. Breakthrough technologies in this case refers to everything which we assume will be available in a future energy system, but currently is not technically available yet, or techno-economically, which in a lot of cases also refers to hydrogen-related technologies. Demands, overall energy demands, sectoral energy demands, and carbon price, among others. And what we can see here in this result, also in the next slide, that the carbon price changes seem to show a higher influence, especially in the intermediate years, so from 2020 to 2035, while in the later years, demand changes show higher potentials or higher effects on the overall results. I don't want to say the word potential here. And this is interesting because it kind of reflects what's also in the public debate or what's in the scientific consensus, is that especially the last percentages of decarbonization are quite difficult to achieve. And demand reductions, which are traditionally something which in energy system models is less well represented due to modeling difficulties, could be a very suitable tool. And maybe there also the need for interdisciplinary research or trying to include these in modeling terms, softer aspects into models could be very important. And this can also be seen in the electricity share the renewable share in electricity, which shows this graph, again, we see that the carbon price in the intermediate years seems to have a stronger effect, while changes in the demand show higher effects in the later periods. Also, interestingly, in this picture and the one before, there aren't that many changes or effects of all the other parameters. Of course, in respective areas, if we would have a graph here which takes a look at grid expansion, the grid expansion sensitivity shows higher results. But for these overarching identifiers, it's mainly carbon price and the demands which show stronger effects. And also one point here is that even though the emission reduction wasn't 100%, the electricity sector and system in a lot of these sensitivities shows that it's completely renewable by 2040, 2045, latest 2050, but there's a lot of sensitivities which go in there. And as a conclusion of this short presentation here, well, I can stress that 100% renewable energy is not only a vision anymore from academia, but already basically made its way into a political debate slowly, not yet totally, but slowly. And it's definitely a necessity for the energy transition. Reducing energy demand, not only through efficiency, but also sufficiency, shows generally the highest effects on the configuration of the energy system, and also therefore the viability of 100% renewables. New investments into fossil technologies must be avoided. There is no point in doing them anymore. And generally, which I didn't have the chance of showing in this presentation, but which is also an outcome of a couple of our studies, is that the benefits of this transition outweighs the cost, which also now in the debate approaching the general election we had in Germany last Sunday was something which was mentioned by a lot of people, that we shouldn't be talking about costs of basically the energy transition, but what the general benefits are. And here on the right-hand side, you can see two example publications which we made over the last couple of years. One is very recent here, and the other one is just an overarching one, taking a look at 100% renewable energies. And with that, I'm happy to finish my talk. And yeah, I'm awaiting your questions.
Thank you very much, Karlo, also once more for being in time. I see a first hand risen by Wolf.
Hi, thank you very much, Karlo, for the very nice talk and such a lot of material. I just had a quick question on your, I think it was slide 9, where you showed the share of renewable in electricity generation. Oh, thank you. And compared to, my impression was that compared to recent narratives that probably we have to do more and quicker in terms of renewable deployment in the electricity sector. This may even look slightly conservative with like 65% in 2030. Could you comment on this? What drives this, that you have this relatively linear, stable increase and not more early action in the power sector compared to the other sectors? Thanks.
Sure. So thank you for that. Very, very good question. Very interesting. So the base scenario, which basically are probably the thing you're referring to, this orientated more or less to the targets set by the German government, which are currently not the current ones anymore, but the previous ones. And so it is a conservative and already today we can say outdated scenario. And everything else, so the deviations from that always only take into account one specific change in parameter, one specific measure. So for example, here we have a change in carbon price, here we have a change in demands. When we're thinking in the end though about how the energy system transformation actually has to happen, it will be a measure and a mixture of all of these measures combined. So it will not only be the carbon price, which will be the final tool. It will not only be demand reductions. And what we showed in this case here is that if we only change one of these things, we already get a significant deviance. If, and that's also one of the conclusions of our paper, though, we change multiple of these things, which in the case of an energy transition towards 100% has to happen, then the effect will be more pronounced. And I therefore also agree 100% with your take that this is very conservative and probably higher amounts have to be achieved and should be aspired to. This is basically more of an academic exercise than like a political advice on how the transition should look like.
All right, thank you very much. And if you want to read more on this, that would be the 2022 article you mentioned in the end.
Exactly, right. Thanks. Which is already basically available. You can already find it.
I think maybe, Karlo, you can also note down the link directly in the chat for everyone so that people can directly then find it online. Mm-hmm. Are there any other questions? Otherwise, I think this is also one of the lessons that not only we, but lots of people that study in this field always have to suffer from, so to speak, that policy is basically, which is good, but still at the same time, it's difficult to make research if policy takes very fast decisions. And therefore, our assumptions being taken 3 or 4 years ago are totally outdated nowadays. So you basically always have to anticipate. And when things need quite some time to go through thorough review process within journals, etc., there's always the risk of things being not up to date anymore. But enough on these techno-economic perspectives. We now want to focus a bit more on social-political aspects, also on opportunities and challenges for structural change in Lusatia. And therefore, I'm very glad that Paula is willing to give a third talk in the first session, basically talking about these aspects. So handing over to you, Paula, the floor is yours.
I hope you can see the screen now. Yeah,
it's good.
So yeah, I would like to talk a bit about like a co-region. So zoom into one region where we face the structural change. And I base my talk on 3 publications of ours, so of the Coal Exit Research Group. First of all, on a peer-reviewed economic paper published in 2019. Then on a book chapter, which was very recently published. It's in German from Nora Stognev and me. And I will mostly focus on this book chapter. So it's part of the book Streitfall Ostdeutschland, Grenzen einer Transformationserzählung. And we also published a booklet on the Lusatia co-region last year. So my agenda is I would like to first of all give some historical background, because I think this is very important to understand challenges in a region, to look into the history. Then I would like to compare a bit the German lignite regions and then zoom into the opportunities and challenges for structural change in Lusatia. And I will give a future research outlook, because we want to continue focusing on this region. And I also put this map here so that you can see where Lusatia is situated. So this was in the former GDR in the eastern part of Germany. And you can also see here that actually parts of Lusatia are in Poland and also a little part in the Czech Republic. So I think it's also a point which is often forgotten, that it's actually not only in a German core region. And now I would like to look into the history. So yeah, the lignite gradually replaced wood and peat in Lusatia and contributed to the industrialization of the predominantly agricultural region. And it was very important for heat and power supply. So in the GDR, this local fuel very much helped that the textile and heavy industry was developed in this region, and it gave the GDR some independence from Soviet oil and gas imports. And it covered around 2/3 of primary energy demand, so a lot, between 1975 and 1990. And it also led to a strong population growth in the region. Many people moved there and found work in lignite and heavy industry. For example, Hoyerswerda was a really small city and then increased a lot due to this industry. And to illustrate a bit this history, I put this picture. It's a coal briquette which was designed in the 1950s, and it's called there's like it's written Flamme des Sozialismus, flame of socialism. I think it very well illustrates like how important this energy carrier was in the past. But now we look into like the present days and how like the coal sector or lignite sector developed. So first of all, I put it like the 3 lignite regions which are left in Germany. It's besides Lusatia, it's Rhineland in the west and the central German district, which is also situated in the east. And it's a much smaller coal region. And here on these numbers, you can see on the left-hand side, the lignite production in 1,000 tons and the employees in the lignite industry. And I think it's becomes very clear that between 1990 and 2020, especially in the eastern German lignite regions, the production really was shrinked like heavily, and also the employees in the lignite industry. So there was already a really big structural change in those regions. And like today there are, or in 2020, there were 7,822 people directly employed in the Lusatian coal region. And I think it's like very important to have those numbers in mind. I just talked to a Canadian podcaster the other week, and she was really surprised that those numbers are actually so low. So I think they are often like overestimated, like the people which are still working in the coal industry. But this is not only about the coal industry. I also want to look a bit broader into this region to understand their challenges and like in order to help them have a successful structural change, because as we all know, we need to phase out coal, and very likely it will happen earlier than 2038 as the Coal Commission decided upon, as Christian already told us. So, and we decided in the book chapter and also in our paper to focus on the comparison between Lusatia and Rhineland, because those are the biggest coal regions left of those 3, and there are quite some important differences. So Lusatia is more rural than Rhineland because there are not that many or not big cities nearby, other than in Rhineland where we have, for example, Aachen and Köln nearby. Then there are the population there are less people living in Lusatia than in Rhineland, and I think this is a very important aspect. The next one, I would also argue that this is actually the biggest challenge for Lusatia. Like more challenges than the coal phase out itself is that the population is aging, and like many people are leaving the region. So the population went down minus 10% since 2000. And in Rhineland, we have relatively stable figures. Then you can see the unemployment rate, which is a bit lower in Lusatia. The regional GDP per capita is also lower in Lusatia than in Rhineland. And I also put like the German average. And the next number, I think, is also really important to understand like how important the coal industry is for the whole industrial structure of the region. These are the share of employees in the lignite sector, which like are part of the social security systems in Germany, and in Lusatia we have there 3.3% and in Rhineland 1.8%. So, and you can see from these numbers, this share is higher in Lusatia, but still it's not that high. And this includes like indirect and induced employment as well. So the employment which has developed because of the payments or because of the expenditure from people who work directly in the coal industry. And now looking into like the challenges and opportunities for structural change in Lusatia. So how can the coal phase out be designed properly? What are like opportunities for this region? How could they change their industrial structure? And I would like to start with the challenges. So as I said, there's this immigration of young and well-educated people. Interestingly, also more young women leave this region than men. And between 1995 and 2015, 18% of the population left. So this is nearly a fifth, which is a lot. Then we have this high-level support for right-wing populist parties. I just looked at the numbers for the federal election. So we have 5 direct mandates in Lusatia, and 3 of them are in Brandenburg and 2 in Saxony. And those in Brandenburg were won by Social Democrats, but those 2 in Saxony were won by AfD. So we have this, high support, which we really need to deal with. And then the more like environmental problem is the increasing water scarcity, which is also linked to the coal industry, because they need a lot of water, because they do this reducing of ground level water. And this will also, we will see in the future, so there are already like challenges to flood former open cast mines, because this is the, was until now the easiest and most cheap way to deal with those former mines. And it's also really beautiful, but when you don't have enough water, then you need to think about something else. And what is also important is that in the face of shrinking populations, the municipalities are faced with the challenge to provide attractive infrastructure for their population, which is important because when we think about how could we attract new, well-educated people, then the soft location factors should not be underestimated. But now looking into the opportunity side, the civil society is becoming more organized. There was, for example, last year, a Bürgerregion Lausitz, so a citizens round umbrella organization founded. It's an umbrella organization for several citizens organizations around the region. So this is a good sign that they are becoming more organized, and also then they have are more stronger and have a louder political voice. Then we have those funds which are distributed in the course of the German coal phase out, and if they are properly used, this could be a huge opportunity for Lusatia. And of course, we always have the question, and what could come after coal? So first of all, there is a lot besides coal already. So this is what I wanted to say before, but still we need to think about which industries could provide decent employment in the future. There's already a huge lots of renewable energy implemented in Lusatia, and one idea or one opportunity would be to attract more companies which are active in Lusatia to really move their headquarters then to the region, because we see that many of those projects are done by renewable energy companies which have their headquarters in Western Germany. And then there's the idea of pushing tourism, and especially with this Seenlandschaft Lausitz, so with those flooded former open coal mines, and those lakes are really beautiful. For example, the Senftenberger See, if you have been there already, it's really nice, but we will see in how far it's really possible to flood all those former open cast mines as it is planned until now. And then we have the challenges of coal phase outs, or we need to have coal phase outs all around the world, and the Lusatia could export their expertise in mining rehabilitation. So this would also be valuable for this region. And now I would like to give a future research outlook, because we want to continue researching this region, because we think that this here we can see how a structural change could be successful, or which policies are needed to make it more successful. And we just published the other week a paper on gender-specific effects of historical coal phase-out processes, and it's a systematic review. And we hardly found any information or any literature on looking at the gender-specific effects of coal phase-outs in Germany. And so we thought it would be worthwhile then to collect our own data. And as I said, more young women leave the region. This would be, for example, interesting to understand better why this is the case, and what those young women would need to change their decision and stay in their region. So this would be like one research idea of ours. And what we also definitely want to do is to look more deeply into participation formats in structural change processes. So there was this Entwicklungsstrategie Lausitz where citizens were participated, and we would like to evaluate in how far those participation formats were successful. We plan to compare it with another participation format, maybe in Rhineland or in another co-region in another country. Yeah, these are our ideas, but yeah, so that was my talk, and I'm happy to get some questions. Thank you.
Thank you very much, Paula, for this interesting talk. Are there any questions by members of the audience? Otherwise, I would have two short questions. The first one is, you mentioned with respect to this demographic differences between the different regions, and you mentioned that you think this is the most important aspect, that the one region is, so to speak, shrinking. Could you elaborate a bit on this? Because you might also say a bit cynical, but from another point of perspective, if we anyhow have less jobs, it's not the worst if people leave the region, because then there is sufficient jobs left for those people that stay there, and that's somehow natural that some regions become bigger with respect to the number of people and other regions are shrinking. So therefore, can't it be also healthy to simply say, well, then let's let this region shrink to an efficient size, however you want to call it? So why would this so much be, wouldn't it be a bigger problem if it would be growing, but at the same time, there's no jobs for the people?
Yes, so I heard this argument often from economists, so this is a very economic argument. Yeah, but I would say that like there are still many people staying in those regions, and we have those negative effects that like then when there's an aging population, we have municipalities which don't have enough money, and then the life quality will decrease further in those regions. So this is like a negative effect after each other. And so I would argue that that there are also many young people who want to stay in those regions, but they don't see like the right opportunities for them. So they are like Lusatian people, as I read, like are also very like Heimatverbunden. So I don't know a good English term. And for example, there are several like Rückkehrerprogramme, like people who want to come back to their hometowns. And so I think there's a huge demand for a live-worthy Lusatia, and many people would like who grown up there would very much value that. So I think we should not leave them behind.
Thank you very much. And then a second question, it's overlapping also a bit with the points that you mentioned now in the last aspects regarding how far is this a problem which can be brought back to coal, or in how far are these aspects which are simply parts of countries in the former GDR? You mentioned also this higher percentage of people voting right-wing parties. This is not a problem necessarily only of the regions of the coal region, Lusatia, but it's entire Saxony, for example, and not everywhere in Saxony people have been working in the coal sector. The aspects about demographic changes is also not only within these coal regions. So in how far is this at all related to coal? What would be your thoughts on that?
Yeah, we see that it is indeed the case that in Lusatia, the votes for right-wing populist party are especially high. So in the federal election in Brandenburg and Saxony together, it was in 2019, they got 2/3 of the direct mandates in Lusatia. So and they are the only party which are still against the coal phase out. So I think it's a very like an issue where they know that they can mobilize many voters, and it's successful. And so I think it's important to look at Lusatia specifically. So I think that this is indeed a bigger problem in Lusatia, I would say. I also see like the more broader questions that we need to design, like structural change and coal phase outs in many different regions in the world, and also from other fossil fuels. And so I think it's very important to look at this region, because it's like the region in Germany which has like faces the most challenges, and we have those funds which are given by the government as decided by the Coal Commission. And so I think it's very important to evaluate in how far those funds are successfully implemented, and how far we can learn something for other regions.
Perfect, thank you very much. Last possibility for other members of the audience to basically pop in questions. If people want to say something, feel free or use the chat function, but this appears not to be the case. So let me just share shortly the program again, so that we basically know where we are and what is following. So I'm proud to announce that we are basically in time. So basically it is possible to stay in time, even if it's a conference hosted by us, which